Welcome to a new video. In this video, we are going to do a data science project. We are going to work on a regression problem. I'm going to leave this datasets link in the description of this video. You can download it for trying the code by yourself. Let's start by importing the libraries that we are going to use. We will import pandas and we will import matplotlib. Of course, we are going to use different libraries too in this project, but for now, these two is enough. Let's load our dataset. For that, we will say data frame is going to be equal to we will use read CSV method from pandas, and we will write the name of our CSV file. Actually, it's lowercase letter instead uppercase, and we can just display it like this and check if it's loaded successfully. It seems pretty great. Also, we can do .head for displaying the first 5 rows. Also, you can specify this, like if you write 3 near, you are going to display 3 rows. If you don't write anything, it's going to display 5 on base. And let's talk about our data frame. We have information about houses, and we can see that we have both numeric and categorical columns. The columns we have are price, area, bedrooms, bathrooms, stories. On the main row, guest room, basement, hot water heating, air conditioning, parking, pref area, and furnishing status. All of these features can affect the price of a house, and we are going to look for all of them in the analysis side, but at the modeling side I'm not going to take all of these features, and I'm just going to select the ones that I think that can affect mostly, and I'm going to create regression models with that features. Let's get general information about our dataset using dataframe.info, and from this code we can see the data types, non-null rows, and memory usage and information like that. Let's get the summary statistics of the numerical columns. For that we can just say dataframe.describe, and we will get the summary statistics. Here they are. We can see the minimum area, maximum area, standard deviation of it. It can give us an idea about how this data is distributed on the area side, and we can see minimum bedroom, maximum bedroom. Wow, there's houses with 6 bedrooms. Actually, I think they are quite large. The mean bedroom, bathroom count, stories, parking, and great. Let's check if we have any NA values. For that, we will say data frame is NA, and if we run like this, we are going to get booleans for the entire data frame. And if we just use .sum with this, we are going to get the counts of the NA values. And from here, we can see that we don't have any NA values in our dataset. Let's check for the duplicates. For that, we will say data frame.duplicated, and we are going to get booleans if we run like that. And if we say sum, we are going to get the counts of the duplicated rows, and it's 0. Okay, let's visualize the distribution of price, and we are going to use a histogram for visualizing that. We will say plt.histogram, and we are going to say data frame price, and we need to use lowercase letter. It was the name of the column, and we will say bins is going to be equal to 20. We can change that. I will show you how it changes. With these values we change, and let's set the color as sky blue. And what else we can do is let's set the edge color as black. Also, we made a mistake. I need to delete this bracket, and I need to put that in here, since in here we are selecting the column that we are going to plot. And let's give it a title like distribution of price, and let's set an X label like price and Y label like frequency. Also at the end we will use plt.show. Here it is. Okay, let's see the value counts of our furnishing status column. So for that we will say furnishing status dot value counts, and I will just run like this, and we are going to see that most of the houses are semi-furnished, and the least value we have is furnished. Okay, let's group our data by this and find the mean price. And we will say data frame.group by, and we will say furnishing status, and we will take the mean prices. So we will say price.mean. And here it is. These are the scientific numbers, and from here we can just say that this is the highest one. Also, what we can do is we can just say sort values, and we can say ascending equals to false if you want to get from the maximum to minimum. And we are going to see that furnished is the most as it can be expected. Also, these numbers says like 5.495696 multiplied by 10 with the power of 6, and you can just think like that. If this plus 0.6 area is same, you are just going to look for the larger number at the starting. Okay, let's sort the dataset by area in descending order. And for that we will say data frame sort values, and we are going to set by as area, and we are going to set ascending as false. Here it is. Let's create a scatter plot between area and price and see the relationship. For that we will say plt.scatter, and we will say data frame area, and then we will say data frame price, and let's set the color as green, and let's set the alpha value as 0.6. Also we need to pass this green value in string, and here it is. Let's say plt.title, and we can just say scatter. Actually we need quotes in here too. Scatter plot of area versus price, and we will say x label is going to be area and y label is going to be price, and we will use plt.show at the end. And here it is. As it can be expected, with the increase on the area side, the price increases. Also here is scientific numbers, so this price are just scaled versions of the real prices. Let's create a bar plot for furnishing status counts. So for that we will say data frame furnishing status, and we will use value counts, then we will use dot plot, and we are going to set the kind as bar, and let's say for the color we can just say red, and let's give it a title like furnishing status counts, and we will set the x label as furnishing status, and let's set the y label as counts, and we will use plt.show at the end. Here it is. Okay, let's get the value counts for main road column. For that we will say data frame main road, and we will use value counts after that. Here it is. As we can see, most of the houses near the main road. Also, let's get the value counts for hot water heating. So we will say data frame hot water heating dot value counts, and we can see that most of the houses doesn't have this feature. Let's also check for the air conditioning value counts, and we can see that most hasn't got that feature. Let's create a pie chart for bedrooms distribution. For that we will say data frame bedrooms dot value counts, and we will say dot plot, then let's set the kind as pie this time, and we will add auto pct as percentage sign 1.1 f percentage sign percentage sign. Actually you are going to remember this if you create enough pie charts. It just labels the data. I'm going to show the difference with deleting it. I will say plt.title, and we will say bedrooms distribution, and I will use plt.show at the end. And here it is. Also, let's just delete the auto PCT in here, and you are going to see the difference. The percentages disappeared, so I prefer to add them. And as you can see, at the y label we have the count, and if we don't want that in the y label, we can just say plt y label and give here an empty string, and now we are going to see the y label is going to disappear. Great. Let's create a box plot for price across different stories. So for that we will say data frame box plot, and we will set the column as price, and let's set by as stories, and let's set the grid as false. And let's give the title like PLT title. We can say box plot of price across stories. And we will say X label is going to be equal to the stories, and Y label is going to be equal to the price. Then we will use plt.show at the end. And here it is. Okay, let's group our data by guest room and find the mean price. So for that we will say data frame group by, and we will group by guest room. Then we will take the price and we will use that mean after that. And here it is. Let's group by the basement and find the maximum area. For that we will say data frame group by, then we will say basement and we will take the maximum area. So we will say area and maximum after that. Let's group by air conditioning and find the median price. So for that we will say data frame group by, and we are going to group by air conditioning, and we will take the median of the prices. So we will say price.median. And let's group our data by main road and find the minimum price. So for that we will say data frame group by main road, and we will take the minimum prices like this. And we can do more group by operations like this. And we can also create visualizations with this group bys. And let's create a bar plot for mean price group by stories. So for that we can say data frame group by, and we can group by stories, and we will take the mean prices after that. And we can just use dot plot at the end, and we are going to set the kind as bar. Since we are going to create a bar plot, let's set the color as orange, and let's give the title like mean price by stories. And we will say X label is going to be equal to the stories, and Y label is going to be equal to the mean price. And let's use plt.show at the end. And here it is. We created a plot with a group by. Okay, so what we are going to do now is I'm just going to call the data frame, and then we are going to select our variables for the modeling side. I think I'm going to take the main road, not going to take basement from the categorical ones, and I'm not going to take others. I'm going to take furnishing status too. So for that too, we are going to use label encoder right now, and we are going to change them into numeric values. So how we are going to do that is I will firstly import it from sklearn, import preprocessing. Then I'm going to initialize it like label encoder is going to be equal to the preprocessing dot label encoder. And then at the next step I will say data frame main road is going to be equal to the label encoder dot fit transform, and we will give the data frame main road. After that I'm going to do the same for the furnished status. I don't remember the column name, it's furnishing status. I'm going to do the same furnishing status, and I will say furnishing status in here too. And when we call our data frame this time, we are going to see that both of them are going to be numeric, like main road is now numeric and furnishing status are numeric right now. Great. So the next step is going to be the selection of the X and Y. For the Y we will say data frame, and it's going to be price. It's easy. And let's call our data frame again for selecting the X. And I think for the X side I'm going to take data frame area, can be 1, and we can take bedrooms, we can take bathrooms. We are going to take the main road, and let's check others, and let's take the furnishing status too, and I think it's enough. And let's quickly call our X in here. We are going to see we have the features that we want. Okay, now we are going to split this data into training and testing sets, and with the training sets we are going to train our models. Then we are going to evaluate their performances on the test set. So for that I will import train test split from sklearn model selection, train test split, and we will say xtrain, xtest, bytrain, and bytest is going to be equal to the train test split x, y, actually it's uppercase x, x, y, and I will say test size is going to be equal to 0.2, which means that 20% of the data is going to be on the testing set and 80% is going to be on the training set. Also for the y side, we need to scale our data since there is so much difference between area and other columns we have. So I'm just going to use standard scaler. For scaling our data, I will just say from sklearn.preprocessing import standard scaler, and I will initialize it like standard scaler. Then I will do scaled xtrain is going to be equal to the, actually I need parentheses in here. It's going to be equal to the scaler.fit transform xtrain. Not for the all algorithms, we need scaled versions like on the tree based models like random forest and decision tree. We don't need to scale our data because the algorithm doesn't need that, but I'm just going to use all of the scaled versions across all the algorithms. And before modeling side, I will just define a function for the evaluation of the model performances. Like when we call that function, it's going to return mean absolute error and root mean squared error. So I will say from sklearn.matrix import mean absolute error and mean squared error. Then I will define a function as model results and I will give the predictions inside of this. Then I will do print mean absolute error on model is, and at the next step I will use that format like this. Then I'm going to do mean absolute error y-test and the predictions that we will pass in the function. So I will just use lowercase letter, and also I will do print root mean squared error on model is, and I will just use that format again. I will just say numpy.square root and we will say mean squared error, and we will give y-tests and predictions in here too. Also we need numpy, we didn't import it, so we are just going to say import numpy as np, and this function looks great right now. It's going to work without an error. That's my expectancy. Great, we will start with linear regression. So we will import linear model, import linear regression, and we are going to initialize it like linear regression. Then we are going to do linear regression.fit scaled xtrain and bytrain. At this step we are going to be fitting our training data, and we are going to be fitting the model on the training data, which means we are training this model on this line, and after that we will store the predictions of the linear regression in a variable like linear regression.predict, and we are going to make the predictions with the scaled x-test. So we are training our model by using fit on the training data, and we are making predictions on the x-test using the model. Then we are taking the predictions and we are comparing them with the y-test in here. So I will just take the predictions after fitting the model, then I will call my function and I will give the predictions that I made with linear regression into the function. So when I run that, we will see mean absolute error and root mean squared on here. These results can be good or bad based on the data and the situation. You are just going to evaluate it on your situation, but what we can do is we can just call data frame price, and we can just say dot mean after that, and the mean is quite large, and I think our scores are not that bad, not too good but not that bad, and we can just evaluate it like this quickly. But actually it depends on the case mostly. Okay, let's train a support vector model and we will use grid search after this model, which means that we are going to do parameter tuning for getting the best performance from the model. So I will say from sklearn.supportVectorMachines import support vector regressor, and I'm going to import grid search for the parameter tuning side, grid search cross-validation, and I'm going to initialize the SVR model with support vector regressor. Then I'm going to define a dictionary for the parameters of the model, like on the support vector model we can say C, it's one of the parameters. We can also look to these parameters from the scikit-learn documentation. We will say 0.01. Actually, I'm trying to add point in there. We will say 0.01, 0.1, and 0.5 on the C side. Also, let's say for the kernel, we can say linear RBF and polynomial. Actually we need codes after all that. And what else we can add in here is, actually we can just press enter for showing it better. What else we can add is, we can add gamma and we can say scale and auto, and then we can do degree and we can say 2, 3, 4, 5, and here it is, the dictionary of the parameters. And now we are going to initialize the grid search object. We can say grid SVR is going to be equal to the grid search cross validation, and we will say SVR model dot, actually not dot, comma, and then we are going to give the parameters we created. And then what we are going to do there is we will just fit this into our training data, which means that we are going to train our model on these parameters. We will say scaled X train and Y train after the fit, and it's trained. We can also see the selected parameters, like let's print best parameters for model is, and we can just use dot format again, and we will say grid svr dot best parameters. And after that we are going to see that the best performing C value was 0.5, degree was 5, gamma was scale, and kernel was poly. And let's do predictions with this model, like predictions grid svr is going to be grid svr dot predict scaled x test, and we are going to call our function again with this predictions grid svr, and we are going to get mean absolute error and root mean squared error. Great. For the final, let's train a tree-based model, like I'm going to train a XGBoost regressor model. You can also go for random forest or decision tree models if you want to train tree-based models. I just want to try XGBoost regressor, and after that I'm going to finish the video. So I'm just going to import XGBoost regressor from XGBoost library. I will import XGBoost regressor, and I'm going to initialize it like XGBoost is going to be equal to the XGBoost regressor, and we are going to define a set of parameters, like parameters grid is going to be equal to the number of estimators, can be, let's say, 50, 100, 500, 1000, and 2000, and we can just set learning rates like 0.01, 0.1, 0.2, and 0.5, and we can create max depth, and it can take values like 3, 5, 7, and 9. And we are going to initialize the grid search object like grid search cross validation. We will say XGBoost for the model, and we will give the parameters grid, and let's just set the cross validation as 3. And what we are going to do now is we will fit this using our training data. Remember that we don't need to use the scaled versions of the x values since on the tree-based models it's unnecessary, but I'm just going to do like that and we'll fit it using ytrain. It's trained in a minute and let's see the best performing parameters like best, and we'll use parameters after that. Learning rate is 0.1, max depth is 3 and number of estimators is 50. Great. Now we are going to take predictions like XGBoost predictions. We will say grid search.predict and we will give the scaled x-test. And then we are going to call our function model results and we will give XGBoost predictions. And here is our mean absolute error and root mean squared error. Actually, I think the best performing one was the linear regression, but I'm not sure. And that was all for this video. What you can do more is you can just deploy this using API, like you can use Fast API. I have a video on it on the channel, or you can just create a web app with this using Streamlit. I also have a video about how you can create a web app using the machine learning models, like how you can get the predictions on the web, and you can just extend this project like that. That was all for me for this video. Thanks for watching. I'm creating content about data science and programming. If you are interested in these topics, you can follow my channel for more. I have more than 20 data science projects on my channel. You can just check the playlists if you want to see more projects like this. Have a great day.